Hello everyone, this is a demonstration on how to take apart the Honda Valkyrie turn switch hardware, generally the 97 through 06 Honda Valkyries. And this is to install the springs and foam to support the SignalBoss auto-canceling plug-and-play turn switch signal system. At about a 15-minute job. Recommend putting a nice white towel across your tank. Loosen up the two front screws on the mirror harness that holds the switch switch package for the interstates, for the dash, and the mirror for the tour and the standard. You loosen those up, move them down a little, and that gives you room to work on this. And two screws underneath, pretty straightforward. There's one long one, one short one. You cannot put them in backwards. There's just no room. You'll quickly realize which one goes where, so I'm not going to worry about that. Again, this is a demonstration, so I have the wiring that you would normally see here running up to the high-low switch. I have that just cut off and disconnected because it makes it easier for demonstrations. But normally that'd be just dangling there, no big deal. You pop this out, you can see the little nub here that goes into the hole in the bottom of the handlebar, and that's for resetting it properly. So you just pop this out, take it off, set it on your dash, and you can work on it. Pretty straightforward system. The design is very standard for all the Japanese motorcycles, Honda, Kawasaki, Yamaha, and Suzuki. There's some minor differences on the inside, but largely the design is based on the same philosophy. Push it to the right. You can see inside that flat lever here, you can see that little white box under there. It stays. See how you can barely see it under here. It stays to the left until you push it to the center, and then that moves the box back to the middle, and vice versa here. For the SignalBoss, we want to convert this physical latching switch into a momentary switch. Physically, this works as a latching switch in that, you push to the right, that box inside goes to the left, and it stays there, it latches. It makes the electrical contact, and it keeps it there until you press to cancel. And that's the latching aspect. What we want to do is insert a spring or foam in here, and a spring or foam in here, in these two spaces on the left and the right side of that white box underneath. So it automatically pushes the box back. After you move it, it pushes it back automatically after you release this switch. And there's a lot that goes into that. The condition of the switch, of the internal, the condition of the insides, how worn they are, the age of the grease, how much that grease has collected dust and dirt over time, and moisture. There's a lot of things that really affect how well the system will work right out of the gate, sticking a spring in here and a spring in there and making it work. I recommend this is a great time to take this switch apart, clean it out completely, do the maintenance on it, and then you'll never have to worry about it again. Most of our bikes are aged, and the internal contacts, the electrical contacts, could probably use a little attention. So you'll notice there's some dirt and dust in here. It's been a little while since I cleaned this, so we'll take this apart. Basically, 3 screws. One of the things I want to notice is which piece of metal is on top of which piece. This retaining part that goes to hold this wiring harness that goes up to the high-low switch, this goes on last. Sometimes that could be confusing. So what we're going to do is take these apart. Remember, this is the kind of white metal you want to not over-tighten. You're not looking at too much. You get it good and snug, and you're good to go. This one we'll take off last. This one actually just connects these two together, and I'll show you how they work. This is the other one. By the way, one of these is really invaluable. I don't know about you, my fingers are not thin and dainty. No harm against those who have them, I just do not have them, so the needle nose really works well. Highly recommend getting one of these. If you get one with the little hook on the end, that's even better. So now we'll remove this, and we'll take a look at this separately in a second. And we'll disregard this wiring harness again. That's for the high-low switch. As you can see, it's basically pretty straightforward inside. You have the horn button here, and you have your contacts here. You actually have, for the North American models, which include Mexico, Canada, and the US, you actually have two separate circuits, one on the top and one on the bottom. For the rest of the models, especially European, you only have one circuit. These two circuits for the US, or the North American model, they work for the turn signal and the second filament in that bulb for the position lights. Everywhere else, they just have a single circuit, single filament bulb in the front for the turn signal. The rear lights are always just single filament with stock. So, pretty straightforward here. This will come out. You can grab it any way you want. It's basically just slid in there, and with age, it might get stuck. So be gentle, but you pop that out and you're fine. Now you can see all the gunk that's in there. I'm not going to put any cleaning stuff in here to show yet, but using Q-tips, which are a great thing to use, look at all this. Look at all this gunk I'm just cleaning off. These things do get dirty. You'll notice there's a weep hole here in the bottom, weep hole here underneath this switch, and they're set in such a way that the air doesn't blow in, it blows backwards, and it lets any moisture drip out. Problem is, you get moisture inside, it collects dirt and dust, mixes with the lubricant that you use on the switch, and that's why you need to do maintenance on these. I don't think there's another way around it, but you can see all this that's on here. These don't have to be cleaned, but I'm just showing you for the sake of what you can expect. And this unit I probably cleaned about a year ago. So just gives you an idea, and it's not plugged in, it's not used on anything, it's just in my shop and on trade shows. So just in that you can see how much has been gathered. So that's just the dirt off of one thing. What I recommend is high percentage isopropyl. The highest the better. It has the least amount of water in it, and you can use this to get in here, really clean out this if you want, as much as you feel you're good for, and it will just evaporate away. Especially on a day like today, it's about 90 some degrees out. So that's what we'll do with that. So we'll set this aside for a second, and we'll look at the electrical switch. I want to show you how this works. This piece has sliding ability here. You'll notice that you have the lever, then you have a brass bushing, then you have a washer. You want to watch about the tightening on these. If you really tighten down, even really well, it should move fairly loosely. If it doesn't, it's either dirt inside or the physical metal is mucked up a bit. So examine that and take a peek. As long as it moves fairly well when it's tightened down, you're okay. What I have done on these, and I'll show you here, is shine these pieces up. One thing I recommend is if you're going to do any cleaning on this, get 1000 grit or 2000 grit, even better, and very lightly. You want these to be as much of a shine finish as possible. Now that's barely putting any pressure on it. It's just doing a cleaning job, getting the bottom there to get rid of any imperfections, physical imperfections in the metal. And that's it. That's all you really want to do. You don't want to do too much on those. Very important to recognize that metal needs to be as pristine as possible. Now you look at these pieces, and you can see this one as well. looking at the angle of that brass, you know, I get very cautious about this, and I'm using very little motion, more so to clean the gunk out than to take any metal off in the shining process. Brass is a softer metal, and you just want to be careful with it. So I'm just using this as a way of making sure I clean all that out. See, I didn't do much at all, and the top doesn't need to be cleaned, as that's where the washer goes. You can see how little it takes to shine that up. And then the washer, again, you don't have to do too much on these. By the way, I like wearing gloves because of skin oil. It allows me to make sure that what I'm working with does not get contaminated, especially working with the electrical contacts, does not get contaminated with standard, oils from your skin. So now we have this. These you could clean fairly well using the isopropyl. Again, I recommend 99%. It evaporates quickly, especially on these hot days, but it sure does a great job in doing the basic cleaning and getting everything ready. So I'm just going to do that here. Just do a little wipe down of everything. I was doing a little with the 1000 grit, so this will take that off. So, that's clean. That's good. That's ready to reassemble when we go to do that. Clean this off here too. Alright, so we're looking at pretty straightforward stuff. You can see I recommend your towel on your tank can serve as this platform. Doesn't take up a lot of space, and your towel will hold things from falling off. So we've got that ready. Now to the electrical. This is the area we really want to take our time with, and patience. Patience is a huge deal with this. I know you want to do a quick fix. I'm like that too. I really recommend taking your time. So here we go. We are going to take this apart. You'll notice there's this little lep here and this little tab here, and it doesn't take much, and it comes apart. So you want to be cautious of that on your tank. Now take a look at something here. I don't know about you, but they don't look happy. They look a little dirty, maybe a little scarred. I've had some customers actually who felt their confidence in a soldering iron was good, and they actually built these up with a soldering iron, and then with 1000 grit or 2000 grit sandpaper brought them back to a clean finish. I'll let you make the choice on that. I don't recommend it because you start messing with these things, you can quickly go south. So this is not much on there. It's pretty much evaporated. Let me do another cleaning. So I'm just going to do a cleaning. I want to show you something. So looking at these contacts, yeah, these do not look happy. These are usually copper clad in some form or fashion. We can talk about oxidation and rust and all that business. The point is that these don't look good, and this is an outstanding opportunity to look at these and go, okay, let's improve them. Your best friend in this case is a good old-fashioned pencil eraser. Do not recommend using the sandpaper, even the 2000 grit stuff, until you absolutely have to. These, watch what happens. I'll just do this one. At least there's just no abrasion on this. It's a polishing effort that I'm doing here. Look at the difference in that, how that get the light to shine. See how this one over here shines up better than all these, just with a few swipes of a pencil eraser. This is old school stuff. It's what we always used in ham radio for cleaning sensitive contacts like this. It's nice to not have to use chemicals, and it shines it up nicely. clean it first to get any dielectric that's on from the past, grease, oil, what have you. Again, the high percentage of isopropyl. Polish these up nicely, and I will use that word polish instead of sanding. This is a polishing process that I'm using. Get them nice and shiny. This is really, really good to do. Now, you're probably thinking, okay, I get them shiny, what's going to happen over time? Over time, if left like this, they will reoxidize and go back to that yucky state that we saw earlier. Got that. What we're going to do is, after we're done, we're going to cover this with some dielectric grease. And this is, dielectric grease has been around in one form or fashion. Those of you who were brave enough to take apart your parents' TV in the 60s and 70s, dielectric grease was caked all around the TV tuner that rotated and clunked. It was used to help reduce moisture issues and such, lubricate the switch. So what we're going to do here is we'll just finish cleaning these up, and I think you can see before and after quite a difference. Now you will notice here, you see this little indentation right there. Okay, this is what customers have looked at in trying to fix. Fixing these don't have too much. There's a little line in here. There's an indentation in here, indentation in here. And these are associated with the contacts and how they connect here, moving back and forth. That's how the inside of that switch works. So it moves back and forth. Pretty straightforward. I don't think something like that needs attention. I would say if it was more serious, maybe. But then again, a switch package like this you can get used for 20 bucks. New, I think it's 40. These are not expensive, and so it's easy to replace rather than spending the time to try and fix it with solder or what have. So we'll leave this one here. This one's good, and then we'll go to this one. Now these things, they do pop out. You'll notice inside there, you could see in behind, you could see there's a spring in there, and there's a spring in there. And then on this side you have this little ball, right? And these tabs. Pretty straightforward design. This ball actually has a spring behind it, and that's used on the receiving side to press against the ridges there. You notice I did a job on those ridges. This was actually taken off of my original Valkyrie, and I was having problems with it. And then when I created the SignalBoss many years ago, I started experimenting with ways of making this work, and one of them was to remove those ridges. I don't recommend you do that. That was just part of my, let's say, R&D process. So doing that. But let's pretend they're not there. I did some alcohol on the swab. You can see it building up. And you want to clean all the nooks and crannies of this. Get it nice and clean. Remove all of the old contaminants, grease and oil. Really do a good job. It helps to make a difference. Don't need to worry about what's going on inside. You could stick some alcohol in there to break it up, but that's also a spring ball. And that's actually very helpful in centering the switch. That does the physical thumb switch centering. So you just want a little cleaning. You don't have to pop that ball out, although you can. Do watch about those springs. They'll shoot right across the room and cause you a lot of headache. So I don't recommend taking the ball out here, and I don't recommend taking that ball out. Actually, in order to do it, there's a way of drilling a little hole from behind, and it's a pain in the butt. But I don't recommend doing that. You don't need to. If you want to clean out what's in there, stick some alcohol on a swab, let it build up, push it back and forth, use an air pressure system, and blow it out maybe. So let's look at these contacts. These contacts, like the others, I don't recommend pulling these out when you're cleaning them because you could really deform them quite easily. I recommend just pushing in, holding it with the tabs somehow, and just doing a light erasing or medium pressure erasing to get to get the polishing action going. That's what you want to do. And again, the contact points are just those little nubs that are sticking out. It's not the flat side that's at the lower level, so you just want to make sure you clean the tops there. Get them nice and clean. Get yourself some alcohol. If you really want to clean this out, you can get a pan of alcohol, the rubbing alcohol, and drop it in there and let it soak if you want for a few minutes. Whatever you're comfortable with. In the end, you just want to get all of the old grease and things like that out of the way. Cleaning the outside, especially the bottom here, because that's what's going to be sliding on the other plastic. So you want to get all that clean. So now we have, electrically, we have these two pieces clean enough. This one is really the most important. This one, you just need to get the bumps cleaned, and you're good to go, but they're clean. So now, how do we protect them from future issues? Some good old-fashioned dielectric grease. I bought this, this is my second tube. My first tube lasted me about 25 years. That's how little you use. This tube, I'm sure I'll pass it on in my inheritance. You don't need a lot at all. You do not want to use a lot at all. It'll just work against you. So what I do is I take a little bit like this. I position the electrical contacts like this, and just a little swipe over it all. That's how I do it. You see there's barely any buildup. Go ahead and once you get it on there, go ahead, just try and clean it off with your finger, because whatever's left is really all that you need. And then of course this one, I didn't even get more dielectric. I just used the remaining that I swiped off. Go here, I'll do just a hair more maybe. See, look how little I use. Very, very little. See, I'm just giving it that coating to cover it. And that allows, in this case, these two pieces will slide back and forth like this. And pretty smooth right now. It really feels very slick. And you can see there's not much there at all. So to me, that's the most important part of the benefit of this maintenance, is reconditioning these electrical contacts so you get good, clean signals to the SignalBoss. There is a difference too in the level of signals. The way this is designed, these contacts are able to withstand, amperages of energy. Each bulb about 3/4 of a watt to 1.5 watts, maybe somewhere around 1 amp per bulb. So you're looking to run maybe 2 amps comfortably, 3 amps comfortably on each one of these contacts. SignalBoss works in microamps, so the sensitivity is much more. So we want these contacts to be very, very clean, so there's good, clean contacts for the SignalBoss to work well on. So that's that. So now we want to put it back together. Pretty straightforward again. You put the contacts in like this. You take the one lever there and the other lever, you hear that click, and then it's good to go. And you can see it moves back and forth very nicely. So we have the unit back together. We did the maintenance on the inside with the electrical. You notice that I haven't gotten into any lubrication on the white box, and I try to use as little as possible. I've tried so many different kinds. Your liquid types of lubrication, 3-in-1. I've tried good old-fashioned locksmith graphite that you would use, the powder that you would use. I've tried that. I've tried a bunch of different things. I'm not going to say one thing works really tremendously well over the other. I think the big difference is particular plastic compound, what it was made of at the time, although I'm sure they have a standard, there's slight variations. And in the best cases, the least amount of lubrication you use, the better. So keep that in mind as you work on yours. And I will admit that some customers have had some real frustrations in not getting to work. Be patient, go slow, take your time. It'll work. It just takes time to learn what your switch likes in terms of being able to move easily. And I know this seems like a lot to do for SignalBoss, but this is the only hinge pin to the SignalBoss working in our Valkyries. Everything else is just super smooth. It works so well. So here we are. We're going to put this back in. So you'll notice the cavity that's in here. You have a corner here, corner here, corner here, and then the receiver for the top. And you basically just slip that puppy in there. Get the 4 pieces aligned up. And there you go. So we got that in there. You could see the movement. That's very smooth. I'm fairly well pleased with that. It's cleaned out. Okay. And so now let's look at the inserts, the springs, to turn this from a physical latching switch into a self-centering. When I talk to you about the white box, this is the white box I'm talking about. We want that to self-center. So I offer two things to do this. I offer springs and I offer foam. And they have very, very different qualities in terms of how they work. In all cases, you know, it's about kinetic energy, stored energy, and you know, you compress it, and that stored energy is going to push out, and they actually refer to the amount it pushes out in terms of acceleration. You know, it accelerates a lot in the beginning to push out, and then it decreases in acceleration until there's no more stored energy. So there's a lot of science that goes behind doing this. It's not just throwing things in there and it works. I think I tested maybe about a dozen different springs before I came across these, and then even still, I felt that this closed cell foam was really good too, and I found that it works sometimes better than the springs depending on the quality of the plastic. So let's try the springs first. You can use a needle nose, right? There's challenges depending on your dexterity. There's challenges with that. And a little slip, this thing will shoot across. I have had customers call me and say, it's somewhere in my garage, 25, 30 feet behind the things I stored against the wall. And, you know, these springs, by the way, they are expensive. Somewhere around $4 each, I know. But they are expensive because there's a lot that goes into these springs. So be careful with the springs. My recommendation is work closely. Notice how I'm keeping my hand capped over it. In case there's a shot, it'll bounce around here. It won't go across the garage. So first thing I do is I move it to the one side, and then I put that spring in. Now you notice I put the small end of the conical shaped spring against the box, the wide end against the outside. That is very important because this box is moving back and forth, and we want to reduce any kind of restriction. If the wide part of that spring is against the box, the perimeter is going to be dragging against this back wall and against these contacts. And not only will it cause restrictions, but it could cause some switching issues. So very, very important to put the small end of that spring against the box. So the first ones are always easy. The second one is always a challenge because, watch this, see, it's automatically self-centering. It's doing what it's supposed to do, but a little bit more. So the other one, we go in here. I know my gloves are, compress it like that, stick it in there. You can see there's problems. Whoop. You can see there's all sorts of different issues. Tweezers help, and I've gotten pretty good at just doing it that way. Tweezers are really good. I think they work better than needle nose because you can slip the whole thing in there. So And you set that thing as center as you can. Remember, you push too much, it'll pop through. You have to take it all apart and work it again. So here we go. Let's see what happens. It's just enough there that it'll self-center. Yeah, that one's not so good. So you see how they're not working quite as well as we want them to. Matter of fact, I would say these are going to be problematic. There's just a percentage more would be perfect. It's not. So this happens. This is why I have the foam. Now I want you to notice the difference. I'll pull this spring out. And this is the way to take it out. You see how I stick something in here? I've also used good old-fashioned dental picks. These are really good because I can get in there and wiggle out, and it can't go anywhere. It's on the dental pick. So let's see what happens with the foam. And this is again used. I'll show you how it is. I try and cut these fairly uniform. The point is you want to fill that cavity with that foam. So you see how that's in there? Right? Now you already noticed it's pushing more against this side than the other. So let's see what we've got here. A little bit more pressure needed, but boy, that centers nicely. And that seems to center. Now notice that. The foam works nicely on the left, and it self-centers, and on the right, it doesn't quite do it. You could also take the original piece that I cut, and with a utility knife, razor blade, very carefully take small slices off if you want to adjust how much compression is needed. Remember, when you go to make the contact, you're compressing that foam. You could reduce a little bit on the edges and fine-tune it with the foam to make it feel just right. Remember, like a carpenter, it's easy to remove wood, it's easy to remove foam here, you can't put it back. So be very careful and work very incrementally. Don't overwork it, get what works, and go from there. What I want to do now is take a peek at how foam works on both sides. See how I pulled that thing off? Can't go anywhere. These are so valuable. So here's this, the foam. That's a big piece of foam that's going in that box. If you look at how much space you're covering, you're going to be covering a whole lot of section in that box. You could slightly trim the sides, trim the top to remove some of that compression factor to fine tune, but we're going to leave it the way it is. We're going to put that in there. Now you see how that's really centered nicely. Before with the spring it was kind of pushing a little to the right. So we've got here and here. Now I could tell you there's a challenge in compressing that, but we're gonna see how the switch works first before we get into doing any trimming. So just to recap, springs and foam, most of the time the springs are going to work well. If you're really having problems, the foam generally just solves the issue and really works out well. So let's put this back together in terms of covers. I'll show you here. We'll put this back together. See this little nib sticking out? Well, that goes down. So this goes here. This goes on. This washer goes on. And then all these screws are the same, so you're not going to have any issues with that. We'll put this back together to make it easier to install. Just a nice tighten. See how comfortable that is moving? Don't need any lubrication on this if you can help it. Remember, lubrication is great, but it will attract things such as moisture and dirt. So if you let it be as dry as possible, that's good. So this is going in. You can see how this part sits in first with that retaining ball, and then the other two pieces line up down below. All right. So now we'll put in this screw. And when you first put it in, just get it rolling. Don't tighten it down yet, just enough to hold things in place. This is how I put them together. You can choose your method, but this is what I do. Then I line that one up. And this one now, you tighten down until it gets, you feel it give, and just a little bit, maybe a quarter turn at most, and you're good. This one here. Oh, by the way, I also recommend getting a JIS. I should be using that all along. P2 by 0.25. These are JIS screws. That one grips. You can feel the grip difference. American Phillips is not the same, so I should have started with that. Yep. All right, so they're good to go there. Now, I think we've got success with the foam. Some things to notice here. One, the physical thumb latch is returning to center automatically. That's really good sign. And then the second thing that you have to look for is the white box underneath. That white box there underneath. That needs to have a space in here to return to center. It doesn't have to be absolutely perfectly centered, as long as it comes off the left edge when you move, and it comes off the right edge when you move. So I'll push this to the left and let go. You could see it's off the left edge by about a little more than 1/8 of an inch. That's great. I'll move to the right, let go. You could see that white box just is right back to center. So this switch is actually in great shape. You can see the little bit of cleaning I've done in there. And the things you'll notice, I didn't use lubrication. I used dielectric grease, which serves as somewhat of a lubrication on the electrical contacts. I did not use any 3-in-1 or any other kind of lubrication. It works great. This plastic likes this approach. Not all plastics, depending on, you know, the exact chemical structure that they use, may not work as well. But those are few and far between. Now, I do have one other trick up my sleeve. Should this not work and you've tried every lubricant available and you're just about to call me up and say, Steve, I'm going to hunt you down, you've pissed me off, and I need some resolve here. So when you get to that state, I do have one more trick up my sleeve, and it has to do with this play. This play, you'll notice the internal white box isn't moving while I'm doing this, right? That's because these pins and the design that we're about to take a much closer look at of the white box inside have a space that was created for the purpose of allowing the switch to stay physically latched while the thumb lever can come back to center. And then you would use the pressure forward to center it, which would disconnect the circuit, and that's how you turn off your turn signal. You push it left or right to turn it on, you push it in the center to cancel it. So these two posts and the design of the top of the white box allow for that. What I have is I've created a little insert that takes up that space. So you see that triangular shape? I'm going to get rid of those screws. See that triangular shape? And you can see the posts. They can move back and forth at this lever and give it that space. So what I've done is, for this area that's it's taken up in, I've designed these, and I get these made, and these are just little inserts. It's fairly successful. I will say nothing is absolutely perfect, but it seems to work fairly well. Let's see how well it goes here. Now remember, we have a working switch already, so this is just an add-on for the conversation. So we'll put that in, we'll put the brass washer down, we'll put the cover washer and the screw. We'll get that in there, tighten it up. So, first off, watch this, no play. Taking up that space, right? But that also means it's quite stiff. What I find is when I use that insert, it works better with the springs. Now see how it does connect to center? But you really got to hanker down on that. So I do suggest if you use this insert adapter, you need much less on the left and the right side of the white box. Use the springs, cut the foam pieces down. That's another approach. You might use maybe half the size of the foam in there. You don't need much at all. And this makes a very stiff push, but it does work. Alright, so I removed the insides adapter, so now it's back to just using the foam. I really like the way this feels. I think this switch is going to be very nice. And I'm going to show you something here with the testing. So I'm going to hook up a multimeter to the center of the one circuit and the normally open circuits of the left and right switch. This actually, doing it here, this actually connects to the what would be the left and right turn signals, not the position lights. So they're normally open unless you make contact. So here we are. Watch what happens. Contact. And this is why we test. Let me see here. So this is why we test. This is that one works well. That one works, but I will say I've got to put some extra pressure on that. The left one, not so much. The right one, I've got to put some pressure on it. So this is the fine tuning that you can do. So that means the right one going to the right, and that space in that right side doesn't need as much pressure. So what we'll do is, let me turn that off. So what we're going to do is we're going to go back to the spring. Hopefully I can pull this out without it falling through. Yeah, these dental picks are amazing to have. So I frankly find it easier to insert the springs with this lever assembly together. I can push that box out of the way, and with my fingers I can get it in there and manipulate it just fine. So that's what I'm doing. So let's see what happens. We'll set up the continuity test. Now see, that's much easier to get to the right, and now the left and right pressure is the same to make the electrical contact work. So don't be afraid to play with the different things that are offered, springs versus foam. I do find over time that a lot of these switches do seem to like foam on the left side and springs on the right. Don't know why, but that seems to be the tendency. So that's the disassembly and reassembly for the SignalBoss, including maintenance, cleaning, and what have you. When you go to put it back together again, this circuitry here, the wiring would be part of that to the high-low switch. You install your slide for your choke, your two screws, you can't miss them. It's pretty straightforward on how they go. This one has a lot more space. This one doesn't have as much space, so the short one goes back here. And the long one goes in here. And there you go, reassembled, ready for use with the SignalBoss. Pretty straightforward.